Hello and welcome to m200 Online Statistics at Cañada College. My name is Lapuz. In this video we will do a homework problem from section 7.3. It says that an IQ test is designed so that the mean is 100 and the standard deviation is 12 for a population of normal adults. Find the sample size necessary to estimate the mean IQ score of statistics students such that it can be said with 99% confidence that the sample mean is within 5 IQ points of the true mean. Assume that sigma is 12 and determine the required sample size using technology. Then determine if this is a reasonable sample size for a real-world calculation. Let's get some information down. The mean is 100. I don't think that's going to be necessary for our formula, but the standard deviation is 12 and a 99% confidence is important. And within 5 IQ points will serve as our margin of error. This is as large a margin of error as we want. So let's try to remember all that. Standard deviation 12, that's sigma. So not just S, but sigma. We want to be within 5 IQ points and with a 99% confidence level. Okay, according to our formula, our N is going to be the Z sub alpha over 2, that's a critical Z value, times the sigma divided by the margin of error E, and the whole thing taken to the second power. We have sigma, we have E, we just need to find Z sub alpha over 2, our critical Z value. Remember, for the norm distribution, that's norm.inv, the inverse norm function, it takes one tail, and the one tail comes from taking 99%, subtracting it from 1, and then dividing it by 2. Now when we do that, we're going to get the left tail, so we want to make sure that we undo the negative sign that comes up here. And after that, we'll put it into this formula, critical Z value times sigma, and then divide by the margin of error squared. Let's first type in our information. That's norm.inv, and then our confidence level. I'm going to put an extra parentheses here, and I will say it should be 1 minus the confidence level. I think I have my formula backwards there. Let's fix that. And then we want to divide this by 2. And for our standard normal distribution, the mean is 0 and the standard deviation is 1. Notice that this is going to be a negative number. We want to make this positive, so I'll just equals negative and click on that cell. And now it becomes a positive 2.576. No matter, we're just going to click on that cell when we need to access the critical Z value, which is going to be in this step. This is equal to the critical Z value. Let's start with a parentheses. And then critical Z value. Multiply that times sigma. Sigma is 12. And then divide that by the margin of error, and then we'll close the parentheses, and then we'll square it and enter. Now this is 38.2. If we round off, we just get 38, but remember, we want to find the minimum number of sample points that we want, sample data points, in this case people, and we want to always round up. So this is going to be 39. Okay, let's try that. 39. Alright, before we go on, let me just fix this a little bit. So I had initially written that this is supposed to be confidence level minus 1. It should really be 1 minus the confidence level. Okay, which is what I typed in here. Anyways, we got the right answer, 39. Would it be reasonable to sample this number of students? It seems like a fairly good number, fairly small. It's not too large. So this is a fairly small number. It's not like 10,000 or 500,000 or anything like that. Okay, I hope that helps.